This is our seventh video in the series of Road to CCNA, and in our seventh video we will be learning about OSPF Virtual Links. Previously we have seen OSPF single mode, and after that we have seen OSPF multi-area, and right now we are going to see virtual links. And let's know what is a virtual link, and we compare with the real life one example in the real life, and let's see what it is needed for and how to configure and to test the virtual links. Let's go open our Cisco packet test software, and we don't be having any uh, topology today that we want to draw in the Cisco packet tracer because it could take a lot of time. Just we directly give the logical devices and configure on directly here. Let's take for routers. We will be explaining all the virtual links and everything while configuring this while building. first we explain what is a virtual links. Virtual link is nothing but when you have a network that is not connected directly or indirectly to the backbone area, that is area 0. You will be connecting the specific network with a virtual link that is connected as a ABR area border router to the backbone area. Let's see how it's going to work. And about the real life incident, let's take uh, let me give a notation. This one has a metro station, and these two are connected in area 1, and this one is separately newly linked metro area. I will be notating it. Let's say central metro. This is a central metro, and this one is city metro, and this one has newly built metro station. This is just to compare to give you a better view on how this virtual link work, not really how it be notated like central metro, city metro like that. And right here central metro is the main primary one, and the city metro is connected to the central metro, and whatever the train will be started from the central metro and reaches to the city metro. And we have newly built this metro station, newly built metro station name we have given here, and we don't have any connection between city metro and newly built metro station. So if you want to connect any road, and if you want to give any information from backbone area or city central metro, let me notate that one also. Area 0 or backbone area, and this one is acting as area 1 or indirectly connected or directly connected, directly or indirectly. Here we go in the notation. This is area 2 not connected. How to notate? Yeah, not connected. uh, or indirectly. Here we have enough notations right here, and this is a backbone area, and this is area 1 that is connected to area 0 or central metro, and every data passes from the backbone area or central metro passes to the city metro without having any connection like with virtual link. We have the physical connection, but we don't have any broken links or broken chain. But for the newly built metro, we don't have any route from this interface. We say from the starting point of the area 2 to backbone area 0. Even though we connect this the whole area to the area 1, if we don't have a services from area 0 to area 2, the trains will be stopped at the end of the city metro right here will be train stopped and returned back to here. We will be having connect in technical words, this router will send the data to area 1, and when if we don't have any connection from area 2 to area 0, we won't be having any route direction. The data will never be passed from area 0 to area 2. So we have to create a path between area 2 interface 1 to area 1. So that's because why you can ask me why we cannot create directly link between area 2 and area 0 instead of area 1, because the interface here will not be connected directly to the area 0. It will be connected to the third router that is in area 1 of the city metro. So you cannot directly give away from newly built metro station to central metro. So if you connect like that, you will be directly connected, so we don't have to give any virtual links. If you don't connect like that, directly connect to the area 1, so you have to give virtual links because the data will be stopped here. It cannot reach. Even though you connect with a physical link, you cannot get any data from this one, because here the physical link is from central city metro or area 1 to the area 0, but not with the area 2. So let's do all these in a logical way and learn what to do in a configuration. We might have kept them. Let's not delete all these. Yes, and let's do connections first. And if you want to take a LAN connection, you can take, but right in this topology we are not taking any LAN. Even though we have a ping connection option from the routers, we can ping from one router to another router using a command line face here. So let's give the connections using the copper crossover because of the same devices we are using. 0 by 0, 0 by 0. It's your choice, whatever the interface you take, not a problem. I'm just, you should, it doesn't mean that you have to take the same interface I'm taking here, but better choose that one you can remember when you're doing so quick. Let's move this away. And for the better thing, let's place a note about the IP address we are going to give in here. I'm going to give 192.168.1.1, and here 192.168.1.2, where I'm going to give 192.168.2.2, whatever you can give, because it is layer class 3 IP address. No IP will be based. We have uh, taught it in the previous classes. 168, what we have in 2.2, 2.3. Let's give 2.3. Here we have A little mistake. Let's correct. Oh no. Right now it's better one. From router 3 to router 4, I want to give the IP address 192.168 dot. What we want to give? 3, 3.3. Here you go with 192.168.3.4. You can also take 2.1, 2.2, 3.1, 3.2. I just took it for making it better way to look. And I want to give the notation right here for area 0, area 1, area 2, and so on. Two half of the interface is going to be in area 0, and here are two interfaces and here are two interfaces. Let's drag it a little. You see we have this one. Let's mention this area 1, sorry, area 0, area 1, area 2. We will have to create the virtual link between R3 and R2 and R3. Sorry, R4 and R3. I'm really getting too much out of the state. Drag it out, drag it down. Not the whole, just the notation. Yes, we got here, and make it a little correct. Everything is okay. Let's configure from the router one. First, we configure the IP address and then see OSPF Virtual Link. You know how to configure the IP address. That's going to be very easy for you after practicing for days and days. Let's see what we have: 0 by 0, G0 by 0, and IP address was again 1.1 into 168.1.1 255.255.255.0. Sure. Interface. We don't have any other interface. If we don't take the LAN network, it will be easy for you to configure the IP address and also the network. We'll get two of the networks. Interface G0 G0 slash 0 IP address 92.968.1.2. Let's hop our connection first. Here you go. We see in here the connection is up, and let's go to router 3, get to enable interface. Let's go back to our router 2 because we didn't configure the IP address for the G0 slash 1 interface. G0 slash 1 IP address 92.168.2. Let's go to R3 and G0 slash 1. 68.2.3 back to the router 2. We have got IP address this one. Oh, sure. Yes, we got our network, and let's configure G0 slash 0 also. When you configure the IP address, please check the interface what we have given under the G0 0/1. We have given the IP address 2.3 like that. Check once and clarify it, or else sometimes it could go wrong and you will be pulling up your hair where do I have did a mistake. Let's go. Usually how about this in a router 2.3 and router 4 right here, and interface G0 0 6 3.4. Sure. See how much easy it could go if you don't take a LAN connection here. If you have a LAN connection, you have to take another IP address for the another interface, and you have to configure the IP address for the PC. That could stretch up our time. Let's configure the OSPF router, OSPF 1. And you have to compulsorily give the router ID, because when you configuring virtual link, it will ask you only router ID, not any router uh, IP address or something. You have to give a router. You can take whatever the router ID with the 4 octets, and mention the network. What are the networks? How you have only one network? We don't have a LAN network. We have a WAN connection from here. 192.168.1.0 wildcard 255. Which area is this interface? On area 0 and done. Let's check do sh IP OSPF name, not neighbor. First check interface brief. Let's see. Here we go. One interface from area 0 and the IP address of the interface 1.1 and the subnet mask cost 1. Cost is how many hops you have. We have only one hop here. State waiting to get the OSPF connection, because we didn't do OSPF connection in this router 2, so it is still in wait state. And check after configuring the OSPF from router 2 also. Let's go to router 2, router OSPF 1 and router ID 2.2.2. What are the networks you are coming in from the G0/1 1 incoming traffic, from 0/01 incoming traffic and 0/1 incoming traffic. This 0/1 in area 1 and this 0/0 in area 0. Let's configure that. 92.168.1.0 and 000 and 255 in area 1.0 in area 0. Mention it area 0. And next network 192.168. Another network 2.0 from area 1 255, from area 0, sorry, area 1. If you see this message loading to full, that means we have formed the neighborship with this network. Let's check. We have completed configuring two of these networks, and let's go back to the router 1 and check if we have getting the state wait to full. Here we already see loading to full, and let's check again. Here see it's a DR, because the this router 0 have highest priority and router ID and all. Here we see it's been state DR. We have discussed about DR, BDR, and all in backbone area. In not because of its have a higher priority or all, but it is in area 0. Every any router that is in a area 0 and primarily that will be backbone router. That's in a DR. That could be a DR route, a DR router like what we say directive or directive router or something we have discussed before. Let's go to here and check if we are connected with the two networks. Yes, you can ask me where is the remaining, because while we configure this message is income in uh, it has reached us, and we still can give the text and hit enter after you done give this message and the completes. Let's go to router 2, sorry, router 3, this one, but notation because it starts from the router 0, router 1, router 2. Router OSPF 1. Router ID is compulsory for us. The router 3 network 92.168.2.0 from area 1. Here see from the router this interface is in area 1, and that will be 2.0 2.0 from area 1, and network 192.168.3.0 from area 2. Let's see before we click on enter. While we typing all these, we got this message. That's why we we could still type, but if we enter it, it will still go 000. We forgot the wildcard 0255. Let's see. Here we go. If we get loading to full, that means we have formed the neighborship. We have been two of the networks. Let's go this router OSPF 1 and router ID 4.4.4.4, and what it will be network 192.168.3.0 from area 2. Sorry, wildcard. That's it. We don't have any other network or loopback or LAN, nothing. We have one interface empty. That's going to be easy for us. And let's create the virtual link. Where we have to be virtual link we have discussed. Let's place a node. Virtual link between now virtual link between area 1 and area 2. Area 2. Yes. Let's go and see the place it between here, and let's go for the R3. Everything is completed here, and let's check the ping first from R1 to R4 if we get a ping or not. Get back here on the right. 168.1 dot, check from 1 by 1. Yeah, we are getting for 1.2, that is this router 2, and let's check for the 2.2. Yes, we are getting, and 2.3. Yes, it is. And 3.3. No way, you don't get it because where you have virtual link, brother? No virtual link right here. You don't have a direct connection from area 2 to area 0, but you have a direct connection with this router from area 1 to area 0. So you get this route from here and back to here, but you don't get this data continuously on to this path because you newly built this area 2. So you have to connect with the virtual link to get the data. Let's do it right now. For the virtual link, we have the command. You have to mention the which area you are in, like which area you are providing the network, that is area 2, and virtual link, and which router you are providing, that is 4.4.4.4. And let's go to router 4. Router OSPF. You already in OSPF mode. When you type this one, you will get router configuration router, and you are already in that mode. It says we have got mismatch ID, so let's check the virtual link with another. Let's change this. Here we have to get no, and let's check if we're getting error message again. If we get again, we will do that again. We have to stop the network and give the network. So we are not getting again. So let's do the virtual link from, that means we are getting the data from area 1 and providing it to area 2. Right now let's check area 2 virtual link with 3.3.3. Let's try the ping from there, the router 1. If still not getting, we will do virtual link between this router 1 and router 2 and router 3, then we will get the ping. We are getting 0. First to ping 192.168.3.3, sorry, 192.168.3.3. Yes, 3.4. Yes, let's go here. Let's try again, and we are not getting the ping. And let's create a virtual link between router 2 and router 3. Already in OSPF mode. Let's do area 1 virtual link 3.3.3.3. Get back to router 3. Oh, area 1. Right now it will possible. Let's uh, from 1 by 1, 2.2. Yes, it's going, and 3.3, and it's going, and 3.4. It's a delay again. We have to ping again and again sometimes, or sometimes it doesn't work. Let's get back from this these two backbone area in, and ping 192.168 dot what we have in 1.1. Because of the direct connection we don't get it. Get back from 1 by 1. Get back here, 2.2. No ping. Let's change this virtual link. Let's say no. Let's say again. Here we see we got the virtual link full to loading, and right now it's possible to give the ping. Here go. Here we go. We got the ping. It's a backbone area 1.1. We got the ping, and let's check OSPF neighbor. So IP OSPF neighborship we have formed. Here we see we form the neighborship with the 3.3.3. One is a OSPF virtual link and one is OSPF gigabit Ethernet. The on OSPF area, and this is our total lab. And let's also check another OSPF. So IP OSPF interface brief. Here we got BDR in a virtual link, and here is our lab. We have completed the virtual link series today. I hope you learn how to do the virtual link within area 1, area 2. That's regarding to our logical topology. I hope you learn this lab, and hope you give me a little support to do more videos. Winding up for today. Tomorrow we will come up with one more lab and continuously for this series completed. Until that, hope you will be learning more and give me more support, and thank you.